Hi there. Pretend this shirt is a function. Turn it inside out. Flip it over, put it on backwards. It is now an inverse function. And that's what we're talking about today. These two are inverse functions. They undo each other. What that means is if I take the first function, f of x, and let's substitute in a number, let's say 10, I would have 10 plus 7, which equals 17. Now take the 17, which is the answer to the first function, and we're going to make that the input for the second function. And we get, it's x minus 7, so it would be 17 minus 7, and you end up with 10 back. Well, this 10 is what you started with. If that happens, these two functions undo each other, and they are inverse functions. Now, the notation for this is a little bit different. It is, instead of giving this second function its own name, like g, you would call this f negative 1 of x. This is the inverse function. And because it's f negative 1, we know the f relates to this f, and that's how we know that they're inverses of each other. Okay, to find inverses, remember the shirt? We have to turn things upside down and around and all of that. So the first thing you do is you are going to change f of x to y. So here I have an example we're going to do. So instead of writing f of x, rewrite it as y equals 5x plus 3. Step 2, switch x and y. So where the y is, it's going to be swapped with the x. So it's going to be x equals 5y plus 3. And step 3, solve for y. Okay, well, I have x by itself over here, but 5y has this 3 added to it. So let's subtract 3 from both sides. X minus 3 equals 5y. Now divide both sides by 5. We have x minus 3 divided by 5 equals y. Now that's the inverse function, and all I got to do next is just rewrite it in function notation. So the inverse function for this f is x minus 3 over 5. Now what I mean by undoing them, look at this function and compare it to this function. This function takes the number, whatever x is, you multiply it by 5, and then you add 3. This function takes that x, subtracts the 3 first, and then divides by 5 instead of multiplying. That's why this is like inside out and turned on and put on backwards. Okay, for this one, we're going to run through the steps again, and this time I'm just going to change this to a y. Now we swap the y and the x. So wherever you see an x on this side, you're going to change that to a y. And then y just changes to an x. So we have 2y plus 1 over y minus 3. Now, to get rid of this fraction thing, you multiply by its own denominator. And we'll do that on both sides. So over here, that cancels out. And what you're left with over here is x times y minus 3 equals just the numerator, 2y plus 1. Now we're solving for y, so I need all the y's to be in the same spot. But before I do that, this y is buried in here. So I'm going to need to do the distributive property first. So I have xy minus 3x equals 2y plus 1. For the next thing, I've got to get, like I said, all the y's have to be over here. So I want to move this y onto this side. It's positive here, so we're going to subtract it. And this negative 3x is going to go on this side. It's negative here, so we're going to add it. You get x, y minus 2y, because it's minus, equals a positive 3x plus 1. Now, I'm still trying to get y to be all by itself, and it's in each one of these terms. So I'm going to factor it out. And we have x minus 2 on the inside. And so we still have just a 3x plus 1 over here. And now we have one more thing to do, and that is to divide both sides by the thing that's kind of in our way right now, which is that x minus 2. Once that's off of here, y will be by itself. So our inverse function is f to the negative 1 of x equals, because it's canceled here, 3x plus 1 over x minus 2. All right, I wanted to do one that would look just a little bit intimidating. We know that this is a y, so let's rewrite and switch our variables around. So I have x equals 2 plus the 5th root of 16y, and all of that is over 2. Don't cancel those. This 2 up here is not a factor, it's being added, so no. But what we can do next is multiply both sides by 2 to clear that fraction. And we now have 2x equals 2 plus 5th root of 16y. You're trying to get y to be by itself. So let's subtract the 2 from both sides. 2x minus 2 equals 5th root of 16y. This radical is alone now. So let's just raise it to a power of 5 and raise this to a power of 5. And no, I'm not going to multiply that out. I left myself a lot of room here, but not to do that. All right, so what I've got now is 2x minus 2 to the 5th power equals 16y. Because now when you take something to the 5th power, it'll cancel out the radical of the 5th. So now all we have to do is divide by 16. And we got it. So our inverse function, that's going to cancel, and there's the y. So let's just go right for the answer. The inverse, this was f, so it's going to be f inverse of x equals 2x minus 2 to the 5th power over 16. Okay, this next part, it could be something you find a little challenging. I'll start simple. So the way teachers like you to do this is by using compositions, where you take one of these functions and you put it into the other one, and you should get the x back, and then you reverse that process. So to prove that they're inverses, I am going to do f of g of x first. And what that means is I am going to take f, and instead of just putting a number in here or something, I'm going to put this entire g function in there. X minus 7. And then you apply the function. Well, the function says you're going to take your x, or whatever is in this spot, and you're going to add 7 to it. So what goes in here is the x minus 7. Then when we simplify that, we're going to get x minus 7 plus 7. And that'll cancel, and you just end up with x, which is that's the proof. If you end up with just an x, then the thing undid itself. Now checking it the other way, g of f of x would be g of x plus 7 and what we're going to get here is the function is x minus 7, but instead of just using an x, we're using this entire thing, so that x plus 7 would go right in here. When you simplify that, you're going to get x plus 7 minus 7. And those cancel out, and then you just get the x back again. That's how you prove if two things are inverses. But I'm going to show you something else you can do, because sometimes this composition of functions actually creates more problems and more mistakes, and then becomes impossible to finish. Well, not impossible, but just really hard. So let me show you another way to do this. If your teacher goes for it, ask them. It just depends on how complicated the functions are. For simple functions like the one we just did, of course, do composition. But for this one, I think what I would like to do is just use a number. So I'm going to go f of x, but instead of using an x, I'm going to use the number 2. And I picked the number because I wanted there to be something on the inside that would be easy to take the cube root of. So 2 minus 1 is 1, and I can take the cube root of that pretty easily. So this number wasn't chosen randomly. I looked right here at what I'd have to do with it. So that 2 is going to go into my first function, and I'm going to have 2 minus 1, and then the minus 2 is on the outside of that radical. Let's simplify this, and we end up with the cube root of 1 minus a 2, which is, the cube root of 1 is just 1, because 1 times 1 times 1 is 1, so it's 1 minus 2, and we get a negative 1. Now what you do with that, whatever your answer is here, remember how x's and y's switch? The answer here has to be the input for the second one. So now I'm going to go g of negative 1. What I've got here then is negative 1 plus 2 raised to the third power plus another 1. Let's work this out. Negative 1 plus 2 is a positive 1, and I'm going to cube that. Add 1 to it. 1 cubed is 1. So I have 1 plus 1, and that equals 2. Now don't get it twisted. You are not literally twisted. You are not trying to match. You're not checking your work. You're checking to see if these functions undo each other. This 2 has to be matching what you started with here. If that happens, if the answer, if plugging in a 2 here gives you a negative 1, and the negative 1 going backwards gets you back to your 2, you did it. 100%. These two are inverses. Okay, when you get the hang of this, you can look at 2 of them and go, yeah, those look too similar to actually be backwards of each other. So your guess is that it's no, but we still have to show it. So let's pick a number to put in there. I want to make this easy, so I'm going to put an x here. I think I'll make that a 1. So I'm going to start with f of 1. So what I have is a negative 4 over 1 minus 1. And then when I work that out, that's going to end up being just a negative 4 minus 1. And I end up with a negative 5. Now remember, this negative 5 is the input for g. So I'm going to go up there and grab my g. So I'm going to go g of negative 5. And we are hoping this undoes what this did, and we end up back at a 1. And I'm going to end up plugging that in. So I have 2 over negative 5 minus another 2. Well, this is just going to be 2/5 positive because this is negative and there's a negative on the bottom, so I end up with 2/5 minus 2. So I have 2/5 minus, I need a common denominator. A 2 would be a 10 over 5. So that's getting me to a negative 8 over 5. Well, this does not match 1. So the answer is no, not inverses. Okay, guys, we are done. I want you to try this one now. Put your answer down in the comments. It's a yes or no. See you in the next one. Don't forget to vote on Sunday for the next video. Bye!